Hi everyone. Today we're going to look at more advanced modeling techniques in Rhino, and some people asked me to do the stair here of the Winton guest house. So we're going to go ahead and try to model this stair. Now the couple of important things is, again, you need to have all of the reference material that you can get, and I'm going to be using the plane here. The plan and the elevation, as well as some reference images on the internet. And it's very important when you're trying to model something like this, because one reference image might not have all the information about the object that you need. So getting back to the stair, I mean, it's a slightly unusual stair in the way that it's doing a couple of very unusual turns. And it also contains some very angular steps, right? So it's not the most safest stair in the world. Now the way I'm going to approach modeling it is I'm going to construct it in 3 sections. So the first section is the bottom section here, which is going to be a horizontal extrusion from a profile. The second section is going to be this top little stair, and it's again profile extruded horizontally, and the mid section here is going to be made up of all of these intermediary steps projected down to form this shape here. So I'm going to guide you through these steps. And the first thing that we need to do is we need to figure out the height of each riser. So the way we're going to do that is, first we're going to count how many steps there are. So there's 17 steps, and now I'm going to measure the distance from where the stair starts. I'm going to assume it starts from the ground floor to the first level floor, which I'm going to be assuming is this line here. So the distance here is 4,225 millimeters. So I'm just going to bring up my calculator here, and I'm going to divide this total distance by the number of stairs. It's going to give me the riser height. I mean, you can assume the standard heights, but then you would need to modify the heights of the roof or the floors. I'm just going to go off this number. I'm going to round it off to 248.5. I'm going to build my first step here. 248.5. So this is my first step. I built it by using holding on to control, move it up, specify, tap in 248.5. Well, sorry, first you have to click the first point, which is going to be at the ground here, or wherever you start. Then the second point, if you want it to become vertical, hold on to control, type in 248.5. It becomes vertical in the reference of the next riser here. So that's going to give you the next step, and we can continue doing that over and over again until we reach the top of this section. However, I'm going to do something different, and what I'm going to do is I'm going to draw the first step, and then I'm going to count how many steps it needs to go up. 2, 3, 4, 5, 6, 7, 8. I want it to go up 8 steps, and instead of drawing it over and over, I'm going to linear array it. So there's a number of array options. I'm going to choose array linear, and I'm going to need 8 steps. My reference point is going to be at the start, and I'm going to reference off the next point here. I'm going to select last everything, hold shift, select the first step and join it all together into one continuous polyline like so. And then to close off this profile, I'm going to use additional polyline, and I'm going to draw in this additional polyline here like this. And now I'm just going to join it all together. Just make sure that it extrudes properly. I'm going to extrude it like this. Looks like extruded on into a solid, which is great. Okay, now the next step is I'm going to model this intermediary section, and in order to do that I need these individual profile outlines of each step. So I already had that, but if you don't have that, you probably need to trace it and create new ones. So I'm just going to grab these profiles and move them vertically. To move stuff vertically, you just press M, enter, V, enter, and then just drag it up. When you press V, it just locks it to the vertical axis. Locks the movement to the vertical axis. So it's M, V, and I'm just going to move it up to 8.5. I'm going to hold Control, just select the next one, move it vertical again, specify, just click enter because it remembers the last number that you put in. So hold Control, left click to deselect, move vertical, and then press enter, and then left click again. I'm just going to repeat that process for the rest of this section here, until I get all of the steps lined up like this. I'm not going to begin extruding these quite yet. Instead, I'm going to draw the last profile of my stair, and I'm going to do it in a very similar way. So I'm going to grab the first point, pull it over here. Oops. Let me start that over. Two for 8.5, and then drag the tread over here, and then array linear, and instead of 8 we're going to use 4, like so. Select last, join, and we have our last profile. I'm just going to select all of this, type in invert, and then hide, and that's going to deselect everything except the geometry that we're working with. I'm just going to finish off this profile here. So we have stairs like this. I'm going to join it together, and I'm going to extrude it like so. And it looks like the extrusion completed perfectly. I'm going to go back to this and just have a look at how this geometry actually operates, and it looks like these extrusions are forming one sort of cubic form like this, and there's like a closed off angle here. So what I might do is I might just extrude this to one of these steps here, and this looks about right. I'm going to extrude the next couple of steps to about the same height. And these I'm going to extrude down to about here. I'm just trying to make sure that the solids are connected by faces. Like so here, for instance, I have a problem because the two solids are connecting by an edge. So what I might do is I might grab a 3-point shape here like this, and I'm going to draw in the rest of this geometry like this. What I might do here as well is something similar, where I fill in this gap with another 3-point box like this, and it looks like we have a reasonable approximation of this stair. So now what I need to do is to just select everything, Boolean union, and then merge all faces, and that will get rid of any overlapping planar faces. So that creates more or less a clean kind of stair. Another thing that I might show you is how we may approach construction of these balustrade pieces. So what I might do is to begin with, we'll construct a few lines representing posts. So we might, let me see how I might want to do that. I'm just going to ignore the fact that the first rail is singular and attached to the wall. So what I might do is I'm going to construct one post, well, number of posts on the outside, and I'm just going to do an outside rail. And the way I'm going to do that is I'm going to construct lines like so, and the balustrade, I believe, is 900, sort of this size, or roughly this size. And I might just copy these posts to these key areas where the stair is actually turning, and it's turning here, and then it's turning at the very bottom here as well. So another thing, it looks like we have 1, 2, 3. There are 4 channels comprising these rails here. So the way I might want to model that is, first I'm going to put points, so divide these lines by a specified number of points. So the way we could do that is to just divide, let's say by 5, and you can see the points being formed. So there's 1, 2, 3, 4, 5, 6 points, and we can use these top 4 for our rail. We can do that to this one, to this one, and this one. In fact, I might so let's draw one channel of that rail, just connecting the top points like this. So that's sort of going to represent our first rail. And then what I'm going to do is I'm going to just copy that rail down 2, 3, 4 times like this until it forms a kind of channel. And here's how to thicken them. So this is a quick way to thicken this geometry. So whenever you select a curve, you can actually run a you can sweep it with a circle. Let me show you what I mean. So if you select a curve and you type in pipe commands, you can specify the radiuses of, or radii of the posts. So what is the radius? Let's say it is 50. No, that's too much. 25. So something like this. So as you can see, it formed a cylinder through this curve here. So that's just a quick way to kind of begin creating our posts. And the wonderful thing about it is that you can actually select polycurves as well. And just gonna create slightly thinner radius through them, and you can begin constructing your railing this way as well. Just going to Boolean union these together. So as you can see, now these things have become rail. And of course you have to kind of watch out for kind of weird intersections, because these are formed out of curves. So you kind of have to watch out for these sorts of things when you begin to project them and make them into a 2D drawing, because that would not happen in a real stair. So it's either, I mean, I would not really go into that much detail in terms of modeling, but I would definitely fix these things up in the drawing. So that's a rough kind of approximation of how to model this type of stair. Another thing that I wanted to show you guys in terms of modeling these things is how to model a window frame, right? So modeling a window frame is something that is very easy in Rhino. So the way to do that is you need a curve profile that approximates this aperture. So the way we're going to extract edges. Let's see, extract edge. Maybe I'm missing something. Maybe it's duplicate edge, sorry, not extract edge. We're going to duplicate these edges here. We're going to join them together, and we're going to get this curve here that we're going to use. Now, if you have a curve that you can use as profile for your frame, you can use that. So these are the things that we'll need. We'll need this curve as an aperture profile, and this curve as a cut-through profile. And I'm just going to hide everything else just for the sake of clarity. And what we're going to do is we're going to run a sweep 1 command, and we select this aperture as a rail, and this profile excuse me. One thing you have to make sure is you would need to make sure that the sectional profile sits somewhere inside so this so this bit here sits somewhere inside this window here. In fact, what I might do is I might just move this profile so that it's inside this window like this, and then I'll move this vertically like so, invert, and then hide. Now I'll try to sweep it. Just going to select this as a rail. There's no enter in between these two, so you just select the rail, then you select the profile, and then you press enter, and then it generates the sweep like this. and you generate your frame. The cool thing about this is that you can actually use any kind of profile you want. So for instance, we can go into plan view here, and we could do something a little bit more fancy, like something like this. Perhaps. So I'm just going to join mirror. And join again, and then close. And then if we sweep one, we select this rail. So I press enter again. Select rail, select section curve, and you can get basically any kind of profile that you really want. So obviously you wouldn't have this round section, but you can apply this to any kind of geometry, not just windows, to the geometry of your project or anything like that. But it's a nice kind of method for doing windows as well. So there you have it. Kind of a very brief introduction to advanced modeling. Thanks for watching, and if you have any questions, make sure to email me. Thanks, guys.